Hello, Chris Tangeris here, Rational Acoustics rally car driver. Going to show you through the concepts and configurations within Smaart V7 DI. So right now I'm launching the program and it's polling my computer's operating system for available I/O devices. When it's finished, it'll launch the program. So we'll just start from the right hand side of the control strip here. This is the input device magic button and its corresponding input device drop down menu. So all of the available I/O devices in my computer are going to show up here. Now for measurement purposes, I'm only going to be using my OctaCapture and my Smart I/O, and you can see I've already given the OctaCapture a friendly name. So let's go ahead and I'll show you more about that. So here we have the driver names, and it says, you can see the driver shows up as Core Audio OctaCapture, and I've renamed it Chris's OctaCapture. And then, so what I'm going to do, because as I said, I'll only be using the Smart I/O and the OctaCapture, I'm just going to go ahead and hide the other interfaces that my computer sees. So when I relaunch DI, if I have my Smart I/O connected, which I'll show you in a later video, that will be the default device, and if not, it'll always go to the OctaCapture. Okay, so the way that we are getting measurements in DI is basically there's two spectrum engines which are paired to one transfer function engine. So when you launch, the default configuration is input 1 and 2 on the spectrum, which are tied to measurement and reference of the transfer function. So input 1 is a measurement and input 2 is a reference signal. So the way I have my I/O configured is I'm going to be using the pink noise generator, and I have the device OctaCapture selected, and then main output 7 and 8. Now 7 is going to a loopback, which is going right to input 2 of the interface, and output 8 is going to an equalizer, which is in front of a speaker that we'll be measuring later. So let's verify that we're getting our signals. I'm going to press play on input 1, make sure it's on OctaCapture, and there's my microphone. I also have a microphone in input 3. The levels are the same. And then input 2 is noise, and input 4 is a equalizer, which we won't be able to show it's making any sound until we turn the pink noise generator. So let's go ahead and do that. So we can see input 2 is leveling in. Okay, so I'm getting all of the signals that I want to see. So let's go ahead and give our inputs friendly names, because that way we're clear on what we're going to be measuring. So input 1, by double-clicking in the friendly name channel for the OctaCapture in input 1, I'm going to name that M30, because I'm using a M30 Earthworks microphone. Input 2 is going to be the generator loopback, so we'll call that gen loop. Enter. Input 3 is a second microphone, which is an iSemcon, so we'll call that iSem. And input 4 is the EQ, which is a physical Y split on the output of the equalizer back to the input, so it's a purely electronic measurement. Okay, so now I've got all these different channels set up, and I'm going to be switching back between them. But what I want to do is have many configured pairs for when I'm doing the transfer function measurements. So this first pair that I'll be using will be the M30 against the generator. So I'm going to name that my M30 or mic 1 pair. So here in the transfer function area, next to the hammer and sickle, or hammer and wrench, which is the shortcut to get to measurement configuration, which I'll show you in a moment, is an aperture icon. So I'm going to select on the aperture icon, and this is going to this is a shortcut to give a quick name to the configured pair. So we'll call this M30, and then I'm going to change the microphone signal and change it to iSemcon. So now it's the iSemcon against the generator, and you see the transfer function change back to default. So we'll name this iSem, And now I want to compare the EQ to the generator. So we'll have EQ there, and then again the transfer function name changed back to default. So we'll change this to EQ. And now we have configured pairs. It looks like I have configured pairs from a previous session, so now's a great time to show you the measurement configuration dialog. I'm going to go and I'm going to delete these pairs that I'm not going to be using. So system, EQ, Smaart IO, I won't be using any of those pairs, so I just have the 3 that I am using. So in here we see that we have the basic settings for our measurements. You can choose to invert the trace, which is what I'm going to do for the equalizer, because when I do a gain or boost, I would like that to show as inverted, so I can do a cut and have it show up as a boost in Smaart, so that I can actually match the equalizer trace to the magnitude trace. So that is an exception. Live measurement, you typically would not invert the trace. So here we see the measurement and reference averaging for the spectrograph are linked, and as are the weighting. We won't be dealing with weighting for the purposes of these videos. And then transfer function, our FFT size is our multi-time window, which is a default setting, and we'll use 1 second averaging and no weighting. Okay, so we'll just go to transfer function mode by pressing T on the keyboard, or you can also select the button here in the window views, and we'll just play through some signals to make sure that we're getting to generate some traces. So I'm going to switch to the M30 pair, and I'm going to activate the noise and activate the transfer function. Track, button delay. Switch to the iSemcon. And we'll do one more with the EQ. Okay. So now we've generated 3 captured traces. These will be our starting points for our measurements. Please come by and check out more videos on DI. We'll pick it up from where we left off here. Thank you very much.